Welcome back to video 6 on trigonometric equations and how to solve them. We're going to look at 8 plus 2 tangent of x over 2 equals 10. In this equation, we're encouraged to find x over 2 first. So we will isolate the tangent of x over 2 by first subtracting 8 from both sides, and that will give me 2 tangent of x over 2 equals 2. Then I will divide by 2 on both sides, and that will give me tangent of x over 2 is equal to 1. Then I'm going to take the tangent inverse of both sides, and that will give me x over 2 equals tan inverse of 1. And we happen to know that tan inverse of 1 is equal to pi over 4 radians. I happen to know that the tangent period is from negative pi over 2 to pi over 2. And so one tangent period looks like this, approximately. And so I need to figure out how to write this for x, the angle x, not x over 2. I can do that by acknowledging that the period for tangent is pi. So I will say this curve for tangent occurs every pi in length. So there will be another one over here, and this just keeps on repeating. Which means that I say plus pi k when I want to represent all the solutions, not just one period of tangent. And so now I'm going to multiply both sides by 2 to clear the fraction and get x by itself. X is equal to pi over 2, distributing the 2 through, plus 2 pi k. Now let's take a look at 3 plus 5 sine of 3x equals 0. Again, we want to find 3x first, then define the period for sine, and then solve for x. I will subtract 3 from both sides, which will give me 5 sine of 3x equals negative 3 on the right-hand side. Then I'm going to divide by 5. That gives me sine of 3x equals negative 3/5. From here, I'm going to take the sine inverse of both sides. And this gives me 3x is equal to sine inverse of negative 3/5. From here, I'll use my calculator. I'll check the mode, and I'm going to leave it in radians. And then I will take second sine, so sine inverse of negative 3 divided by 5. That gives me negative 0.643500088. So let's round to 2 decimals. Let's go with 3. So negative 0.644. Let's think about what sine looks like. Sine is an oscillating function starting at 0, 0, increasing, crossing the x-axis at pi, and decreasing, hitting a minimum, and then coming back at 2 pi. And then it continues to have this same shape as it moves to the right and to the left. That means that if we're looking for -3/5, that's right about here. And if you look at where that value will hit the curve, the function, that's at the 2 quadrants that represent the lower half of the unit circle. That means that if we want to define the different angles that will exist, we will have 3x equals -0.644 radians. If we think about it on the unit circle, it will be -0.644 radians. But then there will also be another value over here in the third quadrant that's also a possible solution. That means that we need to keep track of that one as well. That will be pi, that gets us to here, pi plus 0.644 radians. And at this point, we can then say the interval on which this happens will be plus 2 pi for every additional rotation. And this will also happen at plus 2 pi for the other point at which this will happen. Now we need to just divide by 3. And so the value of x is going to be -0.644 radians divided by 3 plus 2 pi over 3. That's one solution. And then the other solution will be x is equal to positive 0.644 plus pi divided by 3 plus 2 pi over 3. And we're forgetting one very important part. We have to make sure that we're saying plus 2 pi over 3k and 2 pi k over 3 on the other one as well.